It's another Wednesday, and today we're going to be talking about earthcakes. Ha ha ha, you get it? So before we can talk about the cake and how we can use that to understand faults, we need to talk a little bit more about plate tectonics. So this is a different map showing what we've been looking at before. All these red lines are showing the outlines of the tectonic plates. In some places, they're pushing together, like along the coast of South America. This is causing compression, and one plate's going underneath another. In other places, like along the middle of the Atlantic Ocean, the North American plate's going this way, the Eurasian plate is going that way. So these plates are pulling apart or diverging, and this is a place where brand new crust is made. So the hot molten rock that's underneath comes up and forms brand new crust. And then there's other places, like along the San Andreas Fault in California, where the plates aren't pushing together or pulling apart, they're actually sliding past each other, and that's called shearing. So if we think about all of these different plate boundaries, then we can start to think about the kinds of faults or the ways that the rocks break in those areas.
Well, 1 second.
That's the trouble with having children and their dirty little fingerprints, right? Hey, you guys, wash your hands. Okay, so now we're gonna look at the cake, all right? So see, this cake has different layers. How many layers do you see? Well, I count 1, 2, 3, 4, 5 layers, and they're all different. And in sedimentary rocks, this is often what you'll see, is lots of different layers, and they're laid down flat. That's called the Law of Original Horizontality. When rocks get laid down in sedimentary environments, they're usually laid down in a flat, continuous surface. Now, if these were rocks, which one would be the oldest? And which would be the youngest? So when I was putting this cake together, I did it the same way the rocks would do. I had to put the bottom piece down first, right? So that was the oldest layer. And then I put the blue icing. So that's the next oldest layer. Then the orange layer, the yellow layer, and then this layer on top is the youngest layer. All right, are you ready? I'm gonna cut this. Usually we do this using sponges, but we don't have any clean sponges because pandemic. So faults sometimes are straight up and down, but usually they're more at an angle like this. Okay, so I'm gonna try and cut this at an angle, and that's gonna be our fault. And if you, let me get a sharper knife. If you remember, faults are a big knife. Faults are a break in the Earth's crust along which earthquakes occur. Okay, so we've cut the fault. This is the break in the Earth's crust where earthquakes can occur. So now we're gonna talk about all of these different kinds of faults that happen in these different tectonic environments, places where you're having compression or squeezing. And in that case, if I take these and I squeeze them together, this piece is gonna slide up in relation to the other side. You see how that's squeezed together? This is called a thrust fault or a reverse fault. See how the layers moved in relation to each other? This is how geologists that are out in the field can tell the direction that the fault moved. Okay, let's put them back together. Now if we imagine that we're in an area that's pulling apart or is under tension, stretching, if we do that, this block's gonna slide up and the other one will drop down. Okay, this is called a normal fault. And this creates Horst and Graben topography. So that makes basically basins and ranges. This side over here would be the range or the mountains, and this other side would be the basins or the valleys. All right, now let's look at this. Now we're gonna make a road out of sprinkles. All right, let's see. Let's pour the sprinkles on top, and the road's gonna go right across our fault. Let's see if this works. Okay, so we're gonna look at this from the top. If you remember, strike-slip faults or transform faults is where it's shearing or sliding. And so we're gonna slide this one piece over. Bam! Earthquake. See how one side has slid over compared to the other side? So does it look like this piece moved to the right or to the left? I'll turn it this way to make it easier. So let's look at this one. Has that moved to the right or to the left? That looks like it has moved to your left, right? Or correct? So this is a left lateral strike slip fault. And see how that road moved? You see this a lot in California because there's a lot of strike slip faults there. So you'll see a lot of really cool pictures looking down from the sky of how things like fences or roads or even rivers have moved. Okay, now we're going to reset it. And now it's a different kind of fault. It's still a strike slip fault, so it's still shearing or sliding. Boom! Now which side does it look like it moved towards? The right. So this side looks like it moved to your right. But you know what's cool? I'm on the other side, and that side, the other side of the fault, looks like it moved on my right. So no matter which side of the fault you're on, you can tell if it's a right lateral or a left lateral strike slip fault. So I promised the kiddos that now they will be able to eat some of this cake. This is an easy thing to do at home.
Come eat some cake.
With sponges or with cakes or with blocks, and you can see how pulling things apart or squeezing things together can cause them to make mountains and valleys or slide in different directions. If you want to learn more about cakes, you can go to Bake It Till You Make It, Fake It Till You Bake It. It's a Facebook group about baking that is fantastic. So that's all we have for this Wednesday. And again, I will be answering any questions that you have in the comments, and I'll be putting up a lot of really interesting resources about different kinds of faults from the incorporated research institutions for seismology. Okay, thank you. See you next week.